Welcome. Today we solve some problems on probability. First problem is 8 children of them 4 are girls and 4 boys seated in a row. The probability that no two girls will be side by side. Options 1 by 8, 1 by 14, 2 by 15 and 1 by 6. Just now I am repeating the problem once again. There are 8 children, of them 4 girls and 4 boys. They are allowed to sit in a row. The probability that no two girls will be side by side. 2 boys may be side by side, but no 2 girls will be side by side. So for that purpose, there are 8 seats. Suppose this is a boy, another boy, four boys. They take their seats at random. This can be done in factorial 4 ways. After they sit 1, 2, 3, 4 and 5 seats are created where one girl in each place can be seated without violating the condition. The condition is no two girls will be side by side. So first girl can be seated in any 5 of the seats. 5. Suppose the girl seated here, then for this next girl 1, 2, 3 and 4 seats are there. So for the second girl 4 seats, for the third girl 2 seats and this. So 4 girls with that condition can be seated in that way. Now suppose that A is the event that the 8 children can be seated so that no 2 girls are side by side. A is that event. So probability of A is equal to n by n. What is n? Number of possible ways, number of favorable cases, which is factorial 4 into 5 into 4 into 3 into 2, n. And n, all possible ways, that is which is factorial 4, factorial 8, because there are altogether 8 children. So this is equal to, they together is factorial 5. So factorial 4 by, if factorial 5 cancelled with that, 8, 7 into 6 is equal to 4, 3, 2 by 4, 3, 2 into 1, 8 into 7 into 6, 4 into 2, 8 cancels, 2 cancels, so 1 by 14. So 1 by 14 is the correct option. Next problem. The next problem is two dice are thrown. The probability that two dice will show same face. Two dice are thrown, and we have to find the probability that two dice will show same face, that is both 1 1 or 2 2 or 3 3, same face will be shown. Let A is that event. So number of cases which favors this event is 1 1, 2 2, 3 3, this way 6 6. So altogether 6 cases favors this event. And what is all possible cases? This is in fact 6 into 6, not 6 plus 6, 6 into 6. Why 6 into 6? Now, if one shows in first dice, second will show 1. One show in first case, first dice, 2 in second dice, 1, 3. So for 1, there are 6 possible cases. Similarly, for 6, 6 into 6, 36 is the all possible cases. So probability of A is equal to, favorable cases is 1, 2, 3, 4, 5, 6. 6 by 36. It is equal to 1 by 6. Now, if the problem is given like that, two dice are thrown, the probability that two dice will not show same faces is, once again, two dice are thrown, the probability that no two dice will show same face. That is, this will not be happen, this will not be happen, none of these same faces will be happen. So actually this and what we want, it is complement to each other. So if A is that event, so A bar is the event which will not show same faces. So we want now probability of A bar is, we know that it is equal to 1 minus PA. So it is 1 minus 1 by 6. So it is 5 by 6. So the probability that any two faces will not be same is 5 by 6, and all faces will be same is 1 by 6. Now take the next problem. The next problem is two dice are thrown together. The probability that sum of the faces is 8. Two dice are thrown together. Sum of the faces is 8. We have to find its probability. Now, suppose A is that event, that sum of the faces in two dice is 8. So probability of that, it is equal to, it is m by n. M is number of cases which favors this event. It is actually, and then n is all possible events. It is 6, just now I discussed, it is 6 into 6. Two dice are thrown together, so it is 6 into 6. If 3 dice are thrown together, 3, then it is 6 cubed, and so on. Now we have to calculate what is favorable cases. Favorable cases, sum of the faces will be 8. It may happen in first phase 6, second phase 2, 8. 5, 3, 8, 4, 4. Next, 3, 5. Next, it is 2, 6, 8. 1, 2, 3, 4, 5. So these are the all possible ways where the sum of the faces will be 8. No other possibilities are there, because next time if it is 1, then it should be 7, which is impossible. So this is only possibility is that. How many cases? 1, 2, 3, 4 and 5. So it is 5. So answer is 5 by 36. So options I have not given. The options is 5 by 6, 1 by 6, 3 by 8 and 5 by 36. So this is correct answer. Now consider next problem. Okay, just one. Now let us take the next problem. Problem is, one number is selected at random from 1 to 30. The probability that the selected number is divisible by 5. Oh, sorry, this is not the case. Suppose actually problem is this. One number is selected at random from 1 to 100. Find the probability that number is divisible either by 5 or by 7. Or by, okay. And options are 4 by 25, 6 by 25, 8 by 25 and 2 by 5. So now let us see what is the case. There are 100 numbers, 1, 2, 3 up to 100, and 1 is selected at random. Then what is the probability that the selected number is divisible either by 5 or by 7? So suppose A is the event that the number is divisible by 5. B is the event that the number is divisible by 7. So we have to find the probability of A union B, means either divisible by A means 5 or divisible by B means 7 or both, that is divisible by 5 or 7. Formula is, it is PA plus PB minus P of A meet B. Now let us find probability of A. Probability of A, that is, it is divisible by 5. Formula is n by n. M by n. N means all possible cases, that is the sample space. From 1 to 100, we have to select one number. So sample space is 100. And either 1 or 2 or 3 or 100. And favorable case, it should be divisible by 5. That is, it may be 5 or 10 or 15. That is, this way there are 20 cases are there. 20 cases favors this event because 100 by 5 is 20. So it is 20 plus probability of B. This number is divisible by 7. So 100 is the sample space and it is divisible by 7. Now 100 by 7, it is 334, 28. So that there are 14 cases which are exactly divisible by 7 between 1 and 100. 7, 14, 21, and this way 14 cases are there. So 14 is the favorable case. Minus probability of A meet B. That is, both A and B will happen. As before, 100 is in denominator, and now it is it should be both divisible by 5 and by 7. Then LCM is 35. How many cases are there which are divisible by 35? 35, then 70. Next comes 105. But 105 is not within that. So there are two cases which is divisible 35 and 70, which are divisible both by 5 and by 7. So 2 is the favorable case. So our answer is 20 plus 14, 34 minus 2, 32 by 100. So that it is 8 cancelling by 4, 8 by 25. So this is correct answer. Next one. A box contains 4 red and 5 white balls. 2 balls are drawn at random, one by one, without replacement. Then probability that the first ball is white and second ball is red. Options are 5 by 18, 20 by 81, 1 by 3, and 21 by 72. It is 31. Now exactly what is the problem? You see, there is a box, and in that box 5 red balls, 4 red balls and 5 white balls are there. Now 2 balls are drawn at random, one by one, without replacement. Then we have to find the probability that first ball will be white and second ball will be red. Suppose A is the event that first ball is white and second ball is red. This is the event. Now we have to find, these balls are there, we have to find that first ball taken should be white. In the box, there are altogether 9 balls. Of them, 5 are white. So, getting a white ball from them, the probability is 5 by 9. 5 favorable cases, 5 white balls. We have to draw one white ball, and altogether 9 balls are there, means sample space is 9. After taking this ball, the ball is not replaced. So after that, number balls are actual balls are 4 red and 4 white, because one ball already taken from it, and that is white. So after that, we have to draw one red ball. Its probability is altogether 8 balls are there. So sample space is 8 and favorable case is 4. So that it is equal to 5 by 2, 18. So 5 by 18 is correct answer. Best. Okay. Next problem. Let us see. Okay. Today is up to this. From next day, we will discuss few more problems on that chapter. So today is up to this. Okay, thank you.